Hi everyone, it's Miss Haley. This is your first video lesson that I'm uploading to YouTube to help you with your Apex coursework for geometry. So today we're going to be talking about the 6.4.1 study guide, which is actually something we've already learned. So hopefully this is just some good review and preparation for your quiz next week. Alright, so let's pop over to the study guide. Alright, so we're talking about the special right triangles. Hopefully you remember what those are, but if not, that's okay. It's been a couple of months. Alright, so this lesson is about two right triangles. They're special right triangles that are special because you don't need to use the Pythagorean theorem to find their side lengths. Alright, so the first special triangle, if you can remember, is the 45, 45, 90 triangle. So we want to label the sides hypotenuse, leg, and leg. So remember, here we have our 90-degree angle. We show that with a box. The hypotenuse is always the leg right across the right angle. So here's our hypotenuse. That's always the longest side of the right triangle. Okay, and then the other two sides across from the 45-degree angles are our legs. So we have our two legs and our hypotenuse. So what's cool about the 45, 45, 90 triangle, if you remember, is that each of the legs are equal to x, we'll say, or in this case they said they're equal to 1. And then the hypotenuse, that longest side, is whatever one of those legs is multiplied by square root of 2. Okay, so you could also just draw this triangle as 1, 1, square root of 2. I prefer to think about it with the x's, but whichever way you like to think about it, make that work for you. Okay, so the ratio from leg to leg is 1 to 1. What that means is that the legs are equal to each other, which we already knew. The ratio from the leg to the hypotenuse is 1 to square root of 2, because you take whatever one of the legs is and multiply it by square root of 2 to find the hypotenuse. And then the ratio from the leg to the hypotenuse is just 1 to square root of 2. And that's not really how we did it in class. That's a little bit of a different way to think about it, but perhaps that could help some of you to think about it as like a ratio. All right, let's go to the next page. Okay, so in a 45, 45, 90 triangle, so a leg length, if you know the leg length S, how would you find the other leg length? Remember that both of those legs are equal to the same, so if you know that one side length or one leg length is S, that means the other side length or leg length is also S. And then how would you find the hypotenuse? It's just whatever S is times square root of 2. Alright, so then what about if you knew the hypotenuse length? How would you find the leg length? Instead of multiplying by square root of 2, we would take h, whatever that hypotenuse is, and divide by square root of 2. Alright, so 45, 45, 90 triangle, that's how you would find the sides. So let's go ahead and find missing sides. Alright, so they want to teach it with proportions, and that's absolutely fine. That's not how I taught you. So that's not how I'm going to go over it today, but if thinking about it as a proportion helps you, that's definitely a good way to approach it. Let's think about it how we did it in class a couple of months ago. So here's our 45, 45, 90 triangle. We're given each side length. Remember from the table above, if you know a side length and you want to find the hypotenuse h, we want to figure out what h is. It says the hypotenuse length is whatever one of the sides is, whatever one of the legs is, times square root of 2. So whatever one of the legs is, times square root of 2. Okay? So that's the length of the hypotenuse. And if you were to put that in your calculator, that is about 16.97. All right. It didn't ask you to find that, but just in case that was one of your questions on your quiz, you would type this in the calculator and that would be your answer. All right. In the second example, we're given the hypotenuse, but we want to find the leg length. So let's go back up to our table. If we're given the hypotenuse, which we are in this case, each leg is going to be whatever the hypotenuse is divided by square root of 2 instead of multiplying by square root of 2. So in order to find S, I'm going to take the hypotenuse and divide by square root of 2. All right, now I have to simplify that. What happens when I divide square root of 2 by square root of 2? They go away. So the side length of each or the leg length of each, is 6. Perfect. All right, I hope that makes sense. That should just be a review. Now let's think about 30, 60, 90 triangles. This one's a little bit more complicated, but I know some of you actually prefer this one. So the hypotenuse is always opposite the right angle, which is the 90-degree angle. Okay, the short leg is always opposite the 30-degree angle. All right, that's what we call the short leg in class. And then we normally call the long leg the other side, but you can also call it the long leg or the long side. And then that's opposite the 60-degree angle. And it's important to be able to identify the hypotenuse, short leg, and long leg in order to get those side lengths right. Okay, so here's the 30, 60, 90 triangle. All right, so let's say that's our right angle right there. So that means this is the hypotenuse. Okay, the short leg is over here, short side, and then here's our long side. So by definition, this has to be the 30-degree angle because it's across from the short side, and then here's our 60-degree angle. Perfect. So we're going to be using this pattern that we come up with on the next page and solve problems just like we did with 45, 45, 90 triangles. All right, so here's our 30, 60, 90. So our short side, let's say that's S. What's the relationship between the short side and the long side? Remember, that's just whatever the short side is times square root of 3. Okay, and then what's the relationship between the short side and the hypotenuse, which is that long side across from the right angle? It's whatever the short side is times 2. Okay, all right, so there's our pattern. Let's use that to find some ratios and solve some problems. So the ratio between the short leg to the long leg is times square root of 3, so it's 1 to square root of 3. The ratio from the short leg to the hypotenuse is 1 to 2, since you would multiply by 2. And then the final ratio from leg to hypotenuse is 1 to square root of 3 to 2. Again, that's not how we went over in class, but if that's a good way for you to think about it, I definitely encourage you to remember those ratios. All right, so here's our table. This gives us strategies to help us solve problems. So if we're given the length of the short leg, what's the length of the long leg? Let's go back up to our picture. We're given the short side and we want to find the long side. What do we multiply by? We multiply by square root of 3. Oops, that should be a 3. Okay. The length of the hypotenuse is whatever the short side is times 2. Perfect. So when you have the short side, that's actually the easiest situation there. Okay, what if we're given the length of the long side? If we're given the long side, that means the length of the short side is whatever the long side is divided by square root of 3. And then from there, if you find the short side, I'm going to erase that, that looks terrible. If you use that strategy to find the length of the short side, then what can you do to find the hypotenuse? You just multiply by 2. All right, so that should be a 3. This is so hard to write on. All right, so if we're given the length of the hypotenuse, how do we find the length of the short leg? Instead of multiplying by 2, we're going to divide by 2. Perfect. All right, so on to the next page. A couple of problems. All right, so here's our 30, 60, 90 triangle. All right, so what side is this? This is going to be our short side, so let's call that S. All right, and we want to find the hypotenuse. So, again, I'm not going to use the proportion method. If that makes sense to you, feel free. I just like using the pattern. I think that's the easiest way to get these problems done. All right, so if I'm given the short side and I want to get to the hypotenuse, what do I multiply by? Multiply by 2, right? All right, so I take whatever the short side is, multiply by 2, and what's 27 times 2? That is 54. So that's the length of the hypotenuse in this case. That one was super easy. All right, in this case, we're given the short side, and we're given the hypotenuse, but we want to find the length of the long side. I think the easiest way to do that is to take whatever the short side is and multiply by square root of 3. 10 times square root of 3. And if you were to put that in your calculator, it would be about 17. Okay, so either of these answers would be perfectly fine. Alright, so that looks like that's the end of the study guide. Hopefully that kind of jogged your memory and helped you remember the special right triangles. If you have any questions, let me know during our class time via email, whatever you need. And the next video I'll be uploading is me walking through the solutions for the checkup for this week. That way you can prepare for your next quiz. All right, so I hope you guys have a great rest of your day, and thanks for watching.